Welcome to Manifested Publishers.
Hello learners, welcome to our today's lesson. My name is Mwaneki. We are learning chemistry form 2 and the topic is chemical families and patterns in properties. In the previous lesson, we went through the objectives of this chapter and we defined three important terms, which were family, chemical, and chemical families. But I want to concentrate on the last one, chemical families, because that is what we are discussing in this lesson. I said that a chemical family is a group of elements with the same number of valence electrons in the outermost energy level, and therefore they are found in the same group. Elements with the same number of electrons in the outermost energy level are placed in the same group. In this lesson, we are concentrating on the chemical families. As discussed earlier, that elements in a periodic table, they are classified according to two things. One, elements are classified one is the number, one is the number of electrons, number of electrons in the outermost energy level, and second, the number of energy levels occupied by electrons. Number of energy levels occupied by the electrons. So you classify elements according to those two classifications. And again, we are talking about these elements in the periodic table. So when elements are classified according to the number of electrons in the outermost energy level, then this is when you form or when you have a group. So you have a group. Therefore, elements which have the same number of electrons in the outermost energy level, they are found in the same group of the periodic table. And the periodic table, we have 8 groups. We have 8 groups. These 8 groups are just 1, 2, 3, 4, 5, 6, 7, 8. And these groups, again, you say they are written in Roman numerals. Therefore, elements which have 1 electron in the outermost energy level, those ones are found in group 1. Elements which have 2 electrons in the outermost energy level, they are found in group 2. If they have 3 electrons in the outermost energy level, then they are found in group number 3, and so on and so forth. So elements which have the same number of electrons in the outermost energy level. Remember, again, I'm insisting on outermost energy level. When you write the electron configuration or the electron arrangement, the number of electrons which appear in the outermost energy level, then those are now the ones which are determining the group of an element. Second, a number of energy levels which are occupied by electrons. Again, elements in a periodic table, they are classified according to the number of energy levels which are occupied by the electrons. So this classification now forms what we call a period. They form a period. Then we have period 1, period 2, period 3, and period 4. Therefore, in period 1, these elements have only one energy level occupied by electrons. This is where you find elements like hydrogen and helium. Those ones are found in group 1 because they only have one energy level, which is occupied by the electrons. The period 2 is all consists of elements again which have two energy levels which are occupied by electrons, likes of lithium, beryllium, boron, and so on. Then period number 3 contains elements which have three energy levels occupied by the electrons, and we have elements like sodium, magnesium, aluminum, and so on. And lastly, period number 4 consists of elements which have four energy levels which are occupied by the electrons. And in this period we have potassium and we have calcium. That is when you have, that is now when you are studying the first 20 elements which you are restricting, which we are supposed to study in secondary school or in our syllabus. So that is the classification, or those are two classifications which group elements in the periodic table. We are discussing chemical families. Then in the periodic table, we have all these elements which are found in a group. They have certain characteristics, and that's why I say that a family is a group of elements with similar chemical properties. So if elements are found in the same group, then these elements have similar chemical properties. So that one forms a chemical family. So there are around 8 chemical families, but here we are going to measure on only 4 chemical families, where the first one will be alkali metals, that is group 1 elements. They are also called alkali metals. Second, we have the alkaline earth metals. These are group 2 elements. Group 2 elements are also called alkaline earth metals, which is now another chemical families. Then group number 7 elements, they're called halogens. And lastly, group number 8, which are also called noble gases. Those are the chemical families we'll discuss in detail in this chapter. We are going to start with the first chemical family, which is the alkali metals. Therefore, alkali metals. I'm going to draw a table to show you where alkali metals are found in the periodic table. So that periodic table is showing us the position of the alkali metals in the periodic table. So the alkali metals, I need to say first that these are group 1 elements. The reason why they are called group 1 elements because they have one electron in the outermost energy level. have one electron in the outermost energy level. So the electron is just one in the outermost energy level, and that's why they are called group 1. So in our periodic table, this is our group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. So this is the position of group 1. So group 1 elements are in the same column, group 2 the same thing, group 3 the same thing, and all the way up to group 8. Then there is a space in between group 2 and group 3. So these elements, call them transition. They're called transition elements. So when you talk about a chemical family, we are talking about the elements which have the same number of valence electrons in the outermost energy level. So the alkali metals, these elements are, or they include, so the group 1 elements include lithium, sodium, potassium, rubidium, calcium, and francium. So those are elements which are found in group number 1. Then these elements, again, this is how they appear in the periodic table. So you have the first one as lithium, sodium, potassium, rubidium, calcium, and lastly, francium. So they are placed in that order depending on the atomic number. As you move down the group, and moving down the group means from lithium, sodium, potassium, rubidium, calcium, and francium. As you move down the group, the atomic number increases. And therefore, that's why they are placed in that order. But now, in our case, we are going to discuss the first 3 because those are the ones which lie in the first 20 elements. Our first alkali metal element is now number 3 because when you are counting the first 20 elements, we have the first element here is hydrogen, then we have this, the second, the third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, and 20th. So those are the elements we study in the secondary school. And that's why we are going to concentrate on the first 3 elements. I want to start by maybe writing the electron configurations. So the atomic number for lithium is 3. The atomic number for the atomic number of lithium is 3. The atomic number of sodium is 11. The atomic number of potassium is 19. Therefore, the electron arrangement. So the first is lithium. Lithium, the chemical symbol is Li. So the electron arrangement, you've seen that in the previous topic we said that when you're writing the electron arrangement, there are various rules which you follow. Like the first energy level should have a maximum of 2 electrons. The second energy level should have a maximum of 8 electrons. the third energy level for the first 20 elements again should have the maximum of 8 electrons in the outermost energy level. So when you have, let's say 10 electrons, then you need to fill the first energy level first before moving to the second energy level and before moving to the third energy level. This means that before moving to the second energy level, then the first needs to be filled up. Before moving to the third energy level, then you must fill up the second energy level first before you move on, and so on. So lithium, the atomic number is 3. Then the atomic number means the number of protons. And they say that in a neutral atom, the number of protons, they are equal to the number of electrons. Therefore, lithium with atomic number 3 means that it has 3 protons and 3 electrons. So when you're writing the electron arrangement, we use the number of electrons. And therefore, the electrons, the electron arrangement for lithium will be, it has 3 electrons, so it means it will have 2 electrons in the first energy level, then 1 electron is remaining, then the 1 electron remaining, we place it in the second energy level. So the electron arrangement of lithium is 2, 1. Second is sodium. Sodium has atomic number 11, meaning that it has 11 protons and 11 electrons. And therefore, we need to fill the first energy level first. The first energy level will have 2 electrons. 2, it now means 11 minus 2. So there are 9 electrons remaining. Then once you fill the first energy level, you go to the next energy level. You fill it full. So it will have 8 electrons. So 8 electrons. So these are 2 plus 8, making 10. So 11 minus 10, you're remaining with 1 electron. So the 1 electron remaining, you place it in the last energy level. And therefore, the electron configuration should be like that. The next, we have potassium. Potassium, again, the chemical symbols, you need to write them very well. Potassium has 19 electrons. Therefore, you fill the first energy level first with the 2 electrons. 19 minus 2 is 17. Then you can be able to fill the second with 8 electrons. Therefore, these are 2 plus 8, making them 10. Then 19 minus 10 is 9. Then you can now fill also the third with 8 electrons. And now 2 plus 8 is 10. 10 plus 8 is 18. So 19 minus 18 is 1. Therefore, the 1 electron can now place it in the outermost or the last energy level. Therefore, if you look at the electron arrangement, that each of these elements has 1 electron in the outermost energy level. So that 1 electron is what is determining the group of these elements, that all of them belong to group 1 because they have 1 electron in the outermost energy level. All of them have 1 electron in the outermost energy level. And these are now what we are calling the alkali metals. That members of a certain group, they form a chemical family, and that chemical family has the same number, not the same, but the similarity in the chemical properties. I hope you understand that very clearly. That is what I wanted us to learn today. Therefore, before that, then I've said that the alkali metals, then these are group 1 elements. And this is because they have 1 electron in the outermost energy level. They include lithium, sodium, potassium, rubidium, caesium, and francium. And I have listed all of them here. Then this is group 2. They also have similarities in chemical, in their chemical properties. So it's a chemical family also. We have another chemical family, another chemical family, another chemical family, then another one, and the last one. But in this case, we see that we are going to concentrate on only 4, which will be the first one, the second, the 7th, and the 8th chemical, the 8th groups. Those are the groups we are going to concentrate on and discuss them deeply. Therefore, in this lesson, so that brings us to the end of our lesson today. And I will leave you with this assignment. The assignment is write the electron configuration of the following elements. Write the electron configuration of the following elements. These elements are, when you have lithium, sodium, potassium. Then the atomic numbers, lithium is 3, sodium is 11, then potassium is 19. So write the electron configuration of the following elements: lithium with atomic number 3, sodium with atomic number 11, and potassium with atomic number 19. Therefore, ensure that you've done that before we meet in the next lesson. In the next lesson, we are going to discuss the gradation in size between the atom and the ion. Gradation in size between the atom and the ion of elements in group 1, these ones which you have just looked at here. So how do the atomic size and the ionic size compare? Meet you in the next lesson. Bye.